Okay guys, we're going to move on to the next type of graph, reciprocal graphs, and we're going to get stuck straight in with this first question to see what these graphs look like. We don't really have to do much to x in either of these two questions, just replace the denominator with x. But remember, a reciprocal graph is any graph where the denominator of a function is our input x. Okay, so let's start with 10. Let's replace x with 10. I'm going to zoom in a sec here. So 4 divided by 10 would be 0.4, and I'm going to give my answers here as decimals. You could give them as fractions, but I think it just becomes a bit harder to graph that way. Okay, 4 divided by 8 is the same as 1 over 2, which is a half, or 0.5. 4 divided by 4 would be 1. 4 divided by 2 would be 2. 4 divided by 1 would be 4. And 4 divided by 0.5 would be 8. So when we're dividing by something bigger than the numerator, we're going to get an answer less than 1. Okay, and when we're dividing by something smaller than the numerator, we're going to get an answer bigger than 1. And of course, when the numerator and denominator are the same, we're going to get the answer 1. Okay, we're now going to plot this to see what shape it makes. And it just says plot it between 0.25 and 10. And that's purely because that's where all of our x coordinates lie. Okay, so 0.5 up to 8 would be there. 1, 4, 2, 2, 4, 1. 8, 0.5, and 10 was 0.4. Okay, so you can see that it has made this sweeping shape, which I'm now going to try and probably do very badly, connect up with a nice curve, because this is clearly not a straight line. So there'll probably be a pause in the video here where I mess this up a few times, and then it'll appear. Okay, that's what the graph's going to look like. Now, something interesting is happening there, and happens on many types of graphs, but always happens on reciprocal graphs, and that's that the line gets closer and closer to, in this case, the axes, the y-axis and the x-axis, but we'll never actually touch it. If you think about the function, what's going on here, let's say the bigger we make our x value, the bigger this denominator becomes. We're never going to get a negative number, we're just going to get a very, very small number. If that was a million, 4 millionths is a very small number. Okay, if that was 10 million, it's just a smaller number, and so on. It's never actually going to become negative. So hard as it may be to believe, this line is going to get closer and closer to the x-axis, but never actually touch it. If we could keep zooming in and zooming in, we'd see that it just wouldn't touch it. And that's called an asymptote. Okay, and sometimes we indicate asymptotes by drawing a dotted line as close as we can to where that would appear. So it's very hard to actually draw it on the axis without being able to see it. And asymptote has a funny spelling, so I'll just write it out for you. And we're also going to have another asymptote on the y-axis. Okay, and you'll come across further graphs where there are asymptotes involved, especially if you continue with maths further down the line. Okay, that was just plotting a reciprocal graph in one quadrant of a grid. Let's have a look at what happens when we've got all 4 quadrants to have a look at, and some negative numbers to put in as our x-coordinates as well. Right, so I'm going to start with the positive numbers since it seems easier. 2 over 5, 2 divided by 5, 2/5 is 0.4. 2 over 2 would be 1. 2 over 1 would be 2. 2 over 0.5 would be 4. Okay, and same x coordinates, just negative, so 2 divided by negative 0.5 would be negative 4. 2 divided by negative 1 would be negative 2, and so on. I'm just going to get the negatives of those values I had over on the right. Okay, so let's plot these. I'm going to start just by plotting the positive coordinate. So 5, 0.4. There. 2 up to 1. 1 up to 2. And 4 sorry, 0.54. Okay, so I will actually have the same sweeping shape that I had in question 1 over here as well. And I know I don't have coordinates to go further than those points, but I know what general shape it will make, so I'll keep going a little bit. And now I'm going to plot the negative coordinates, so -5, -0.4, -2, -1, -1, -2, -0.5, -4. Okay, so I'm going to get the same shape. Whoops. Same shape, but in the opposite quadrant. Okay, and that's what we have there. And again, we've got asymptotes on the axes, which applies to both parts of the graph. These two parts of the graph will not touch, but are part of the same equation. Okay. So immediately recognizable themselves, reciprocal graphs, in that they make this shape. You can manipulate them and move them up and things by doing the same sort of things you do to other graphs, adding numbers at the end and stuff. But you should be able to recognize that these are reciprocal graphs. You may get a question in an exam where it just shows you a kind of shape of an equation and a few equations, and you need to be able to recognize that anything with the x on the denominator of an equation would match a graph of this shape. Okay guys, thanks for watching.